Okay, I think we're live now. So how's everyone doing? I am for sure gonna wait for the YouTube notification here saying that I've actually started streaming, and then we start talking, but let's just get going with this for now. Yeah, I think we're actually live now, which is good. Let me just make some audio checks. Yeah, I think we're actually. Yeah, you guys seem to be able to hear me fine. So, welcome to a stream, guys. It's been a while, actually. I do apologize for that. It's been quite a while since I've done the last stream, right? And that was, I think it was last week on Monday or something. I usually try and do 2 streams a week, and once a month I try to do a long sort of form video. But obviously, as you can probably tell in the last few weeks or so, I've had basically zero motivation, which makes it extremely hard for me to actually want to create these kind of like long form videos and just stream in any format. So yeah. But I'm happy I'm back now. And I think I've managed to gain some motivation back. I have uninstalled all of the games that I've been playing recently, which is, something that I was doing quite a lot actually, and this is always a bad pattern that I get into. I always kind of start playing games and I start wasting time in one way or another, and I end up not having any time to make content. I end up not having any time to kind of learn anything new. So yeah. Susie Tags. Oh, that is a Susie Yags. That is a name that I've not heard in ages. So welcome to the stream, man. How is it going? It's been a while, hasn't it? It's been a while. But with all that said, I'm happy to be back and I'm happy to create some more content. Now, I decided to actually take the ECS project to a different level, to another level in general. So now that I've got some sort of like a usable ECS, and I basically worked on it very, very hard on the last weekend, because I wanted to kind of change the way which I stored the entities, the components, and it ended up working in the end. So now that I've got that done, I actually want to use it somehow, right? So the best way to use an ECS is probably inside a game engine. So I thought, why not? Let's revive one of the old projects that we've got here, and yeah, let's just improve it and see if we can get something like the Raylib or something, a very, very basic sort of rendering engine going, and I'll be very happy with that. Yep, been under a rock for a while. Yeah, that's what I was gonna say, man. I think it's been months since I've heard that name. I've seen that name. So, in fact, it might have been on this very same project last time I was working on the audio visualizer, which is going to turn into a rendering engine. That's probably last time I saw your name, dude. But yeah, I hope you've been doing well, and I hope you kept going and you haven't given up. So anyway, so what do we have here? So the idea is to turn this audio visualizer project, which in turn is a Qt 6 / OpenGL project, into a render engine, right? So something that you can kind of pass in meshes, you can put in, you can read in like model files, so object files, and then it will just render for you. And we're going to be starting from that. We're going to be starting from this audio visualizer project that was never really finished. And this is something that I do quite a lot. I never really finish. I start projects, but I never finish them. And it's something I have to improve. Hello, Tom. How is it going, man? By the way, guys, please like the video. It does help me out quite a lot. Like and subscribe if you haven't done so. But yeah, we're going to take this unfinished project. I'm going to analyze it for a bit, and I'm going to see how I can kind of improve this, right? So it does actually compile right now, by the way. So if I do build this, if I'm not mistaken, it still compiles, and we do have like a very simple project that renders a cube that doesn't really work very well because oh gosh, I'm not sure if you could hear that, but it's a very, very, very basic attempt, a very bad attempt, in fact, to render some audio, and it doesn't really work well. But it does render something, right? It does do this. It renders a cube. Now, the problem is that the cube, the faces aren't kind of being Z buffered from the looks of it. So there is already a bug on that. But yeah, let's improve this and turn it into a proper game engine, right? So as I said, I do want to, I want to merge my, I want to merge my ECS project with this one. So I already have an ECS project somewhere, which I can just kind of clone again. So I think it's called it ECS. Okay, GitHub. Yeah, so this is the project that we're going to be kind of basically pulling with perhaps a simple CMake fetch content, right? Because CMake, when you're working with C++ and CMake, CMake has this weird, it's not really weird, but it has this really interesting feature where you can pull GitHub projects and build them as part of your project. So kind of like a package manager. It's not really a package manager because it lacks many of the features that package managers have. But the point is we have a CMake project here and we're just going to be pulling it into our project and we're going to be building it. So let's do that, right? So first of all, I believe I actually have to create a release here, or I can just pull a commit. Yeah, let's do that. Let me just see in what state I left this project. And then we're going to be using fetch content to pull the ECS into the audio visualizer project, right? That's what we're going to be doing here. Ooh. Of course, Visual Studio is deciding to update itself without asking me. I'm sure there's a setting I can change somewhere so it doesn't do it automatically. It's quite annoying when you're on the train and you have very sort of limited internet connection and Visual Studio Code decides to download like a gigabyte worth of updates and it just takes like 2 hours. That has actually happened to me many times. It's not just one time, not just 2 times. Like, I mean, every time I get on a train and it's like a 2-3 hour journey down to London or something, I go through the same problem and it annoys me. But it seems like I pushed everything yesterday. Not Qt content for a while. Yeah, so no Qt content for a while, but you're in luck because this is essentially going to be Qt content. And yeah, welcome to the stream, Bram. This is the first time I'm seeing that name, so you know, very welcome. I hope you enjoyed the stream. So I pushed everything yesterday, right? So with this in mind, what I can do is I can copy the SHA here, and I can go into my project, which is here, and we can include fetch content declare, right? So include fetch content here, so we have fetch content declare GitHub. I think it's GitHub repo, something like that. Oh, nope, that's a different tag. So GitHub tag. I actually need to look at the documentation for this. So for those who just joined, we're just basically integrating the ECS into the audio visualizer project, which is the starting point for this rendering engine, right? So it's a Qt project, which doesn't yet have an ECS, but that's what we're doing in this video. I'm going to try to integrate my ECS into it. Now for that, I'm using fetch content. So CMake's fetch content stuff. And as I said before, I'm going to say it again just because it's worth it. There's more people watching now. There's like 3 more people watching, so welcome to all of you. So fetch content declare and fetch content make available are very good ways of basically just taking someone else's CMake project and including it as part of yours, so you have access to their targets and you can build everything as part of your project. So it's kind of a kind of like a package management thing with CMake, but not really a package management. It's just a very kind of bare bones way of doing things. So this is what I'm looking for. We have Git repository and Git tag, and for that I need to have the name of my thing here. So ECS and Git tag. Now in the tag, I'm going to put my most recent commit. That should work. And for the Git repository, it's just the URL for my repository. So what are the best tips you can give to a beginner wanting to become an expert in Qt programming? PS, the Qt docs are horrible, X. Yeah, they are. They're horrible, but they're still better than most C++ documentation. Look, I'm going to be honest. I'm not really a Qt programmer. I've worked with it. In fact, my first ever job was maintaining a Qt application, so I did have a lot of experience with Qt 4 at the time. I worked slightly, well, just a little bit with Qt 5, and now this is Qt 6. So I'm trying to gain some experience, but like I am not really a a Qt programmer. However, what I can say is that it's a very easy framework. I mean, you probably learn the most by just kind of using it, to be honest. And I view Qt as something like Boost. It's just a library or a framework that's giving you like quite a lot of functionality that the standard doesn't already have, right? So Qt is very good for things like, you know, having cross-platform GUI applications. It just, you know, that's what it's for basically. But it also has cross-platform like networking, audio, and all of those things, and a bunch of utility stuff. So it's worth learning it. It's worth learning it. Quite a lot of companies kind of use it. And now we have fetch content, make available. I think that's the. Let me save this and then see if this is going to actually pull things. So this should go into depths. There you go. And you can see that, you know, this is what fetch content declare and fetch content make available will do for you. So it will go into my repository and then pull everything. Now, the problem here is that I don't have raylib on my ECS stuff. Sorry, I don't have raylib as part of the dependencies for my project here. And my ECS project is relying on that, right? So for the sake of it, I think we're just going to add it to our component file here. Do we have a component file? Yeah, we have a component file.py. So I'm just going to add a self.requires, and it's going to be whatever raylib, I think it is on 5.0.0 or something. Let me just check. Just so we can get the whole thing compiling. That's what we're doing here. 5.0, that's the one. Now it does mean that I kind of have to go and reinstall my dependencies on here. So colon install debug build missing. Oh, hold on a second. So this should have an output, or an OF, I think it is. Thanks. What do you think of Rust? Is it the next big thing and a replacement for C++, or is C++ 20 beating Rust? So I've actually, you know, I can give you some opinion on that one because I've actually worked with Rust for the past nearly a year and a half, and I've recently kind of moved back to C++ at work. But I like Rust. I do think very highly of it, and I kind of used to be kind of like very, what's the word? I'm not gonna say a hater, but I didn't really like Rust before doing it, just because I thought it was kind of just a hype. The things that Rust has, C++ already has, but it's not completely true, to be honest. Like once I started working with Rust, you kind of realize that yes, there are things that you just can't really get with C++ out of the box, and that's like all the kind of compilation checks, all of the niceties of the compiler, all of the nice errors that the compiler tells you. So if you get something wrong in Rust, there will be like a message saying what code you've got wrong and how you can solve that compilation issue, and perhaps what you meant to do. That is very, very difficult with C++, and it's absolutely like useful to beginners, I would say, just because you can learn faster, right? But at the same time, I don't think Rust is going to replace C++ at all. I mean, if you think about the applications of C++ in the past 20, 30 years, it's basically everywhere. And because of that, there's like a lot of software that has been written and is still maintained. I'm talking about software that's like 10, 15, 20 years old. And these things will never, ever be rewritten in Rust, because one of the things that kind of happens the most is like you don't want to rewrite something because you will introduce bugs, you will introduce kind of like security CVEs, for example. And those are very common in code that's rewritten. So not everyone is going to want to do that, right? However, you know, if I was to write a kind of very simple web application, I would 100% go for Rust over C++. Yeah, it's just easier to do. Hello, Robin. Hello, Robin. How is it going, man? It's been a while, hasn't it? So I've not been kind of very active in here, and yeah, apologize, man. But I hope you've been doing well, man. I hope you're doing amazing, especially now that you've had some time to celebrate finishing university, right? And hopefully you're still finding a job or looking for a job or found a job, hopefully. Yeah, I wanna hear it all, dude. So I wanna hear it all. I don't have Coke Zero today, unfortunately. Yeah, it's been a while indeed, yeah. So I'm just for an update for you guys, I'm just rebuilding some of the stuff here. It's actually rebuilding everything. I didn't want it to rebuild Qt, but it seems to be doing that. Right? Which is a shame. I should have done this before. But oh well. Hello, Vlad Antonio. Antoniuk. Hello, Matt. Hello, Vlad. How's it going, man? Welcome to the stream. Looking kind of slow in the tech market now in July, sadly. Yeah, so I agree, man. It's very slow. Look, it's not just in July. It's been like that for the past year or so. I'm gonna be honest. So it's a very slow year. There are very few kind of available positions out there, and there are many people in the market because they've been like fired in the last year or so, as well as new people graduating. So you kind of have like this bottleneck where, you know, the roles that you have available aren't sufficient for all the people hiring. Plus, companies they seem to be hiring less graduates, so it's unfortunate, really. But you know, as a bit of motivation to you, you know, hard times hardly ever last for a long time, and we've been having a hard time in the industry for like the past 2 years or so now. So let's you know, cross fingers that in the next year or so things will improve by quite a lot. Is it better to freelance and get rich without trying? Quote 50%, yeah. Or get a 9-to-5 job after which you will be able to pay for rent or food. So Bran, I'm guessing that you're new, dude. I'm guessing that you're either just getting started or you've like recently graduated or something, or you're learning to code by yourself. And in that situation, I'll definitely say try and get a few jobs first before you go freelancing, because you will learn quite a lot from just working in like large companies and large teams that you wouldn't learn by yourself at home. Like, first of all, if you're just freelancing and doing things by yourself, you're kind of lacking that experience of like having, you know, 2 or 3 people you can ask questions to, and where you can like sit down on a call or sit down in person, for example, and then just go through a problem and solve it very quickly and find out how they would do it. As well as like just general experience of like frameworks and stuff that other people just have. And then once you have that experience, you can start doing freelancing. I wouldn't say, you know, just drop your job straight away. You should probably never do that when you start freelancing. Just do it on the side until you get like a good sort of like credit score in freelancing, shall we say. Once you get like a good reputation, and then once you're starting to pay more for more bills and you know things are getting serious, now is the time to drop your job. But at the very start, always try to find a job. That's my idea. I've freelanced at uni, to be honest, and it's usually like a race to the bottom when you start. So like you can never bid for a job too high because people just won't get you, and you're competing with like 100 different people who are charging very cheap for the same job. So it is kind of difficult. Robin, but I have a meeting now in August for a consulting firm, and we have a lot of ideas we work on besides searching for potential clients. That is good, man. That is very good. So Robin is a very good example of someone who does freelancing and is very good at it. So, you know, that's probably a better person to talk about when it comes to freelancing. Very curious about the changes you did in ECS. Will you walk us through them? So Vlad, 100%, yeah. Let me just get this compiling first, and then we talk through that, right? So let me just see like where we are in the compilation. Oh, it's still building up here. Still building OpenSL. So let's do that. So let's go through ECS here. So actually, it's probably just worth looking at this. So one of the like longest things that I've been trying to do in the ECS is kind of store. Let's open Excalidraw here. I was actually using this diagram yesterday to like mentally think about everything. So previously in the ECS, I'm not sure if you remember, I'm not sure how much of it you actually watched, but we were storing all of the entity data in tuples, right? So for example, this was actually something like a tuple of type 1, type 2, and so on, right? Type 3, Can I increase the size of this just to make my point here? So that's how I was basically storing things in, you know, components of an entity. So we had the entity ID as a pair. So we had a pair of entity ID, and the second value was a tuple, and it was a tuple of a variant. Was it a tuple of a variant? I can't remember now if it was a tuple of a variant or variant of a tuple. Sorry, no, it was just a tuple, no variant, right? So yeah, it was a tuple of optional types, right? So these T1, T2, and T3, they were all optionals. So depending on what kind of components you have for a particular entity, that particular place in the entity, in the tuple will be populated with a valid optional, right? Everything else will be kind of like a no lock. Now, this was all being stored in an array, so in a vector, right? So this is all being stored in a vector where I had like multiple of these. And that's okay. I mean, it's okay if you have one or two components, right? If you have more than that, this will not be cache friendly at all. And this is not going to be cache friendly for one reason. So the size of a tuple is the union of the size, the addition, the sum of the sizes, right? So for example, to store a tuple of 64 optionals, that tuple is going to have the size of 64 optionals, right? So that's if you have like 64 components. And maybe you can store like 50 of these in L1 cache, and then once you go to L2 and L3, you can store like thousands. But it's not very cache friendly, just because the size of the thing is very big. So the idea was to actually move this component type here, the tuple, into a variant, right? But that kind of implies that we have to change the storage a little bit, because instead of being able to store all of the entities as one element in a vector, it would have to be multiple elements in a vector, right? So first of all, what I did is I changed the tuple to a variant of T1, T2, T3, right? So it's only one of those types at a time, and that essentially means that a particular component in the storage here in the array would have a element size of whatever the maximum size of T1, T2, T3, and so on and so forth is. That's what variant is a union, right? So that's what unions are. It's just like whatever maximum size you have it is. And I would recommend, if you don't know what unions are in C++, take a look at that, because they're very, very, very interesting. This is basically the motivation for having variants. So variants are a type-safe union in C++. But also, that change kind of meant that I have to store multiple entries for one entity, right? So, for example, if I have entity ID 5 that has type 1 component and then the type 2 component, so the first element in that array would actually store a pair of the entity type, the entity ID 5, and the second one would be the variant with the type 1 data, and the second element in the array would be entity ID 5, but the second part of my pair here would actually be the type 2 data in a variant, right? So essentially I had a way, I needed a way to kind of return a view into this, so like I can kind of iterate through these in the following fashion. So I have, if this is the entry for component type 1s and type 2 here, components. So say we have this array. Can I increase this? Perhaps not. There you go. So if this is my array, I essentially just need to iterate like 2 at a time, right? So the first one will be type 1 and the second one will be type 2. And that is basically the change that I've made here. And I know it's very difficult to read, but it is what it is, right? So that's what we have here. And the main thing that I have is like this entity view class that I created, which actually takes in a span, so a view into the entity data. As you can see here, the entity data is just a pair of entity ID and variant type. But it also has a function called component. So if I say, entity view dot component circle, it would actually work out which position in this kind of view that component is. So let me just take it back to this. So if I say, I want the first component here, that entity view would work out which one of these 2 elements that component data actually is in, and it would convert that to you in C++ already, right? This is what this is the main change here. So it's kind of usable now. It is not completely right because I still have issues with this. For example, variants are raw component data, right? Yeah, so variants are the raw component data. That's exactly right. And the thing with variants is that the variant data is actually stored. It can be stored on the stack, right? So it doesn't really require dynamic allocation, which is not the case with any. I think it is. So std_any is a different type of doing the different technique of doing this is called type tuning, I believe it is. So I'm using the variants to store the data. But yeah, I mean, this is what we have here. Now, I believe this is probably going to fail. It's still going. This is still going. What are we actually compiling here? I have no idea. OpenSL. Maybe. This is actually taking a long time, isn't it? Yeah. Well, in the meantime, let's actually look at the program and see if we can understand what this was doing, because I haven't actually still made a plan on this whole thing. So the main audio visualizer executable here, it creates a Qt GUI application, which is a Qt class, right? This is not an abstraction by me, and this is just a basic application. Let's just undo that application. And then we have a function that's going to parse the arguments for us, a Qt command line parser. So someone was asking me if I actually like Qt and what I think of it. I think it was Bram, right? So this is the reason why, Bram. So Qt has absolutely everything. So if you want to parse command line arguments and you already have Qt in your program, it's just a matter of integrating a different header, and you have like Qt command line parser for you. And yeah, it's quite good. So yeah, we pass the arguments, and the arguments are, I guess we have the audio file that we pass into this that is going to play at the start of the program. This is not really important to us anymore, because the focus is not to play audio anymore. That's not what we're going to be doing. Then we get a value of the thing, and then we create a QSurface format. What is this for? What is QSurface format? I have no idea. Set sample 16. Let's take a look at that, because I have no idea what this even is. No idea. QSample format. Have I spelled it right? So QSurface format, my bad. So the QSurface format class is an abstraction of renderable surfaces in Qt. So detailed description. The size of the surface is accessible with the size function. The rendering specific attributes of the surface are accessible through the format. Is this just so we can set the size of the thing? Maybe it is, maybe it's not. Let's take a look. Yeah, I still don't know what set samples does, in fact. Because we pass in this surface format object to the set format. But we also set the window size and we resize it here and we show it. Anyway, so this is creating a Windows, this is creating a window, which is a triangle window. And this is something that I've actually, I do remember abstracting this from Qt, and it's just so we have access to all of the OpenGL functions within my window object, right? So you can see here that it inherits from Qt OpenGL window, and that class itself inherits from Qt window and Qt OpenGL functions 4.2 core. And this is what actually gives you the OpenGL functions. So if you're working with Qt and you're trying to work with OpenGL, take a look at these classes. So there's like Qt OpenGL functions and then underscore and the version that you want, and you just basically include that particular header, and you have access to a lot of the OpenGL like functions like GL clear. As you can see here, there will be some more as well. Let's see if we have the shader stuff. Is it going to be here? No, it's probably going to be on the shader abstraction. But anyway, so we have this OpenGL window class, which gives us a render function that renders to a Qt painter. I have no idea what this even does, so it's unused basically. We don't do anything with it. The render function actually does some stuff though, so it clears the color bits. So if we have a device, what is a device? So Qt Paint OpenGL device. I have no idea why we even need this, and also why don't we have one of these boys here? So it clears the buffer bit, the depth buffer bit, and the stencil buffer bit. So we just clear the window, and then we set the size of the device to the size times device pixels. What is that? So Q size type. See, this has been so long that I don't even remember what these classes do. But I guess a Qt OpenGL paint device, just by the looks of it, is something that lets you paint on it, right? So you can do a draw on a surface or something. And then we set a Qt painter, we render, we create a Qt painter, and we paint the device from the looks of it. We render that. Yeah, this is actually unused, so it doesn't do anything, which is interesting. But oh well. So render later. Yeah, I don't remember why this class is a thing, to be honest. So render now. It must be like Qt OpenGL window event. When we get an event here, and the event is an update request, we render now. So this must be the function that's actually drawing things, right? So let's take a look at it. So render now. So if it's not exposed, we don't draw anything, which makes sense. Just gonna change the code styling a little bit. So I'm just taking a look at the OpenGL stuff here. Anyway. Yeah, so this is mostly going to be like us looking at the code that we already have. So if we draw now, and we have a context, an OpenGL context, or if we don't have one, we create an OpenGL context, and then we make the context the current one. Fine, I understand that, that's okay. So we have a Qt OpenGL debug logger. That's interesting. I've never actually used this in the past. So, okay. So if it needs to initialize, we initialize OpenGL functions, and this is something that you have to call within Qt, just so you initialize all of them. And we also initialize. Interesting. No idea. But this must be like a call to the superclass functions. And then we render. Okay. And we swap the buffers. Yeah, so rendering doesn't actually do anything. We do absolutely nothing. So it must be that we are actually... Yeah, so we are actually overriding these things, as you can see here. So these are virtual functions which we must override from inside here, right? There you go. So we have a render function right here, triangle window. Oh yeah, and this actually does something. So we do render, retina scale, width, height, and refresh rate. mRenderer. So what is mRenderer? It's a unique point to my renderer. And that is interesting, isn't it? So what do we have here? How do we create this? Okay, that's something I abstracted myself, you see, and I have no idea how this even works. So again, the renderer class inherits from the OpenGL functions 4.2, which gives me access to all the OpenGL stuff. And I have a bunch of stuff here that's looks quite promising, to be honest. We have a shader, add shader thing in here, which I believe is going to be some sort of like enum attached to the string view or data. Maybe not. Oh no, it's just a structure that says, here's the vertex data, and the vertex shader, the fragment shader data, and so on. And I guess what we actually do here is like we will compile. There you go. So we create the program, we'll compile the program. Okay, so yeah, compile the program by making calls to OpenGL. And this is another thing that I've abstracted the shader program. That is cool. So if there is no shader, we don't set it. So add shader from source. Now, why does this have access to OpenGL stuff? What is my shader supposed to be? A shader program. Okay, so all the OpenGL functions have been called from the shader pointer. Do you learn more from reading docs or the source code, or how do you do it? Now, good question. So generally, I kind of learn more by just doing something, to be honest. So like if I have a project, like this one where I'm making a complete rendering engine using OpenGL and Qt, I will probably learn quite a bit from about Qt and OpenGL just by doing it. And yes, that does mean that I have to read the docs quite a lot. And at the start, like in today's video, we don't really understand most of it, but these are something that we will be kind of looking at the docs and understanding things in more detail. But you should never ever read the docs first, man. Just like don't read docs preemptively. That's what I'm trying to say. So in other words, you want to learn Qt, what you don't do is you start reading all the documentation for it, because you're not going to learn anything by doing that. However, you will learn Qt by kind of just like getting started with a project and learning bits about things that you are touching. So for example, you want to learn about how to create a Qt application object. You will be creating that the actual class for the application, and then you'll be like referring back to the documentation on how you should do things. But yeah, let me know if that made sense. If it didn't make sense, happy to re-explain that. Thanks a lot. No worries, man. I'm just taking a look. Like we're still building the release mode for Qt here, and you can see that's taking a long time here, guys. that's why I'm reading the whole thing here, so like we can revise what is already done, and we can sort of get started as soon as the compilation is done. Yeah, but as I said, the shader program class is actually like abstracting the whole shader creation in OpenGL. So for those who don't know, or for those who have never worked with OpenGL in the past, especially 3.2 and above, you have the concept of a shader. So a shader is basically a program that runs on your GPU, right? So when you run a game, the game engine will either like compile the shader program at runtime or pre-compile them sometimes, and that program is at the runtime of the game that is like sent to the GPU so we can like run it. And what that does is it basically just like renders things. So it tells the GPU, sometimes the GPU as well, like with the CPU when you don't really have a GPU, but you have support for OpenGL on integrated graphics, for example. You're running that shader program in the bare bones like metal of your CPU too. And there are different types of shaders. So there is the vertex shader, which basically takes in the vertex input, so like a buffer of all of the kind of like triangle data, or the triangle data that you want to render, as well as things like normals. What else can we have? Like UV stuff, and pass in and kind of pre-processes that and passes it on to the fragment shader, right? So the vertex shader is very important in kind of preparing those vertices to be rasterized by the fragment shader. Wow, so cool! Like where you are heading. I can't wait for your game, your game released. Hello, John. Man, it's very nice to see you here, John. It's been a long time, dude, hasn't it? But yeah, man, this is just the first step of hopefully creating some sort of game engine, because I'm sure you understand, John. So for those who have just joined us here, John is a game developer and he knows what he's talking about, and he knows that it's very difficult to create a game engine from scratch, especially using C++, right? And yeah, continue on the shader stuff. You also have geometry shader, which I don't really know much about. I never really used them, to be honest, apart from like extrapolating like vertices to create like different geometry types, for example. So instead of like passing on triangles, you'll be passing on things like, I don't know, quads, or I don't even know what the geometry shader is used for. But then at the very end of it, you have the fragment shader, which is where you kind of take in your vertex data, and you're essentially working on each fragment that's going to be rendered on the screen, right? So you are interpolating the color data, the texture data, and displaying that the color. So that's essentially like an overview of the shaders. And for those who are interested, I mean, this is the link here that you can probably read more about shaders. Very interesting indeed. So yeah, this is a very good website, actually. I mean, I remember being at university. This is maybe 7-8 years ago, and I was learning OpenGL from this website. And every now and then, when I learn OpenGL again, I find myself learning through this website, which is actually really good, right? So update on the compilation. We are kind of nearly halfway there. So we're like kind of 30-40%. What a day. What a lovely day. Hello, Arkona. Hello, mate. Hello, Ahmed. It's very good to see you here, my man. It's been a while, hasn't it? It's been a while. Partly because I've lacked the motivation to actually, come online and do some stuff, but we're working towards improving that. But anyway, so this the whole vertex shader is created, or not just the vertex, but the fragment shader. They're created from text files, right? So in a text file, you will have something like a program. Let's see if we can find here an example of it. We should have an example of a shader somewhere. Let me just do a big search here. So GLSL. Or maybe we don't. Maybe we have shaders.h. Let's see where we use shader program data. There you go. So this is what the source file, kind of source code, actually looks like for one of the shaders. This is a very basic one here. Let's see if we can understand this. You may be thinking that this is C++. It's not. It's a language called GLSL. It's very similar to C and C++ though. But yeah. So at location 0, we are taking vertex position, which is a vec3. So you can see here that the vertex shader is taking in from the program the input of a vertex position, which is a vector of dimension 3. We take in a color as well. So this is an RGB color between values between ranging from 0 to 1. And then we also take a UV, which is the texture coordinates. I don't think I'm using the texture coordinates at all at the moment, but it is something that I wanted to build in from the start. And the output of my vertex shader, as I said, the things will be processed here and be passed into my my fragment shader is the fragment color, right? And we also take in a uniform matrix, which is the world matrix, where we take into account rotations and things that make your objects kind of look like they are in the world, right? We'll talk about. This is a whole other topic which we'll discuss later. A lot of linear algebra, a lot of perspective perspective matrices and stuff. So we'll look at this. So we are doing some new stuff here. I don't know why I'm doing that, to be honest with you. But I set my GL position to that. And then I also output the fragment color. Okay, interesting. So you can see here that my actual position that I send to this GL position is something that's kind of like caught on the well, no, it's not something that's caught. GL position is what tells OpenGL the position of a particular vertex, right? And you can see that we transform that by doing the matrix times the vertex, which is fairly standard stuff, to be honest. So that will be like, that'll be transforming my vertices into the world position. And we also send in the color detail to the fragment here. So we have a very, very basic kind of fragment shader that just paints whatever fragment we're on now in the GL position with that particular fragment color, right? How do you catch errors in your shader code since it looks like C? Good question. I mean, truth is, I don't really know. So like, how do you debug GLSL? That's a good question. I believe that you can use the OpenGL like get error stuff to get very kind of high level errors on the compilation of your shader. So for example, if you try to compile a shader that doesn't really work, so let's just remove this here, right? So if we have, let's say we remove that semicolon, this no longer works because it's not really valid GLSL. I think that the compilation of the shader will fail, and if you use the GL get error function, it will actually tell you something. But I've never really tried that, to be honest. You don't catch errors, you just don't make them while writing shaders. Exactly. So Arconaf is another very experienced game developer. So that is the thing. I'm not sure if you agree with me, Arconaf, but I find it very, very difficult to actually debug OpenGL. And when you move like down the stack, like debugging shader code, to me is just unheard of. Like I just kind of retry writing everything when I don't know what's failing, to be honest. Now, if anyone knows a very good kind of reliable way to debug GLSL, to debug OpenGL, please let me know, because I'd love to hear it. But that's one of the things that I hate the most when working with OpenGL. It's just a lack of debuggability, shall we call it, right? But anyway, that is it. So updating the compilation, we're nearly there, boys. We are kind of 2/3 of the way there. So I have only used HLSL through Unity, which magically catches all errors 10% of the time. Yeah, nice. So that's, what is HLSL? How does it differ from GLSL? So I guess GLSL is for OpenGL and HLSL is like a higher level thing for Unity. Is that correct? But I've never actually used HLSL. It is something that keeps coming up every now and then because most people are writing shaders for these game engines anyway, right? So like Unity and Unreal, and they have their own shader languages. So I'm not sure if that is the case with HLSL. Is that correct? But anyway, going back to the renderer, so we have the shader program, which is a class that basically just abstracts all over that like shader creation by calling the OpenGL functions through its shader object, as you can see here. So for example, we add shader from source. This will make a call to, where are we? This will make a call to the OpenGL add shader from source. Wait, from source code, what? Is that something that I did? I was expecting a call to like, what is it, GL create shader and stuff, or compile shader and link program or something. So GL shader data, shader source, that's the one. Replaces, no, this will replace the source code of the shader. So yeah, I mean the interesting functions that we're looking for is like GL compile shader, GL create shader, that's the one. So we create a shader pointer, and then this will return the thing. And after we do that, we actually have to kind of shader source. That's the order here. So we do a GL create shader, GL shader source, and then you do a GL compile shader, I believe it is. And at the end of the whole thing, you do a, once you have like your your fragment shader and stuff, you have to create a program. So GL create program, I think it is, which is like a shader program where you can attach the vertex shader and fragment shader. And yeah, you've got a valid like OpenGL like shader set. But this is what this whole class will kind of do in the end, right? That's what we did here. And if you are interested in catching the stream while we did that, feel free to look back at, you know, I think it's October last year, October 2023. That's when I was doing this stuff. Right. Yeah, so this is by itself, it's like Qt's own abstraction on the shader stuff. So this is like a step above that. But we have link, that's cool, attach shader. Yeah. So we just use Qt's stuff to actually compile the shader, which is fine. Then we have get matrix uniform. Okay. Yeah, and this is where we get like the pointers to uniforms. So uniforms are basically like global variables you can have in your shader programs, right? So for example, if we look at this one here, we have this matrix uniform. So this is like a variable that's available to us where we can set data into it from our C++ program into the GPU program. And these are, you know, uniforms, that's what they're called. And these are like shared by all the instances of that shader program that's running on your CPU. So you might be running, I believe, multiple instances of the shaders in your GPU, right? So HL, Arconaf. HLSL and GLSL are different but the same. HLSL works object-oriented, like where you declare some variables and then functions and then batches of passes. If GLSL is C, then HLSL is C# like. Cool. All right. So can you compile HLSL with OpenGL? Is that a thing, or do I need to like create shader HLSL? So how do I compile HLSL? Is it just the same as kind of? Is it like a Unity thing only? That's what I'm wondering. Because I've seen HLSL files many times, but anyway, I'm gonna assume that it's only like a Unity thing, right? Okay, compilation done here. And what did it do? We actually just compiled in release mode, right? What we do need to do is compile in debug mode, but this won't be long because we already have the debug mode binaries there. Okay, so debug is not a thing, but debug is a thing. So the only thing I expect to be compiling is raylib right now. There you go. So you compiled everything. And that means we can hopefully still build this. No, Microsoft has some compilers. All right, so this is a Microsoft thing for HLSL. Configuring incomplete. So we managed to break something. What have we broken? Could not find package, another dense. Oh, right. So this is another one that's coming from the ECS. All of this, guys. So we just can, so we can just include the ECS. Free fetch content declare, right? That's why I've like triggered the whole recompilation, and that's why we branched off actually reading the current source code so we don't waste time. So yeah, let's look at the column file again, and this is where I kind of do a self that requires this. Let me just sort all of this because it's making me annoyed. Oh. Okay, so let's try and reconfigure the cache. So Microsoft GSL, we're still missing a bunch of them, which is fine. We can just search for it here. So Microsoft GSL. another very good library for those trying to learn C++. I've spoken to this. I've spoken about this on the stream before. So where's GSL going? Around here. Okay. So let's reconfigure this. Oh gosh. So benchmark.config. Another one. Jesus Christ. They just keep coming. This is all from the ECS as well. It's all from the ECS. So benchmark will be around here. Self.requires that, and then we put and install again. Is this the first stream related to the game engine, or were some others? So good question. This is the first one. So this is where I'm basically trying to get an idea of what I'm gonna do. And we've only been working for like an hour, and I've still not done much. But what we did do, Arconaf, is to kind of pick up one of my Qt projects that I've had before that already has like a GUI framework on it and integration to OpenGL. And we're going to start from there. So we're going to start from all of that, basically. So Google Benchmark is actually taking a long time to compile. Let's reconfigure. I'm guessing Gtest is going to be missing now, so they can probably just save us some time, and there you go. So Gtest is missing. We're gonna pull that as well. But yeah, Arconaf, I'm hoping to get some very good ideas from you, Guy, because you know your stuff around game engines. I know nothing. So yeah, what is the goal here? I mean, game engine, is a big yeah, it is a big one. So I'm not really gonna do a game engine, man. So what I want to do is like some sort of framework that lets you create a window and draw some meshes, right? So you can have like an object file or some other type of 3D files, and we can use async to kind of pull those. So basically, we're going to integrate this library and then allow the user to have like a sort of like a UI to just load meshes, right? I'm hoping to use async, because async is something I've worked with in the past. My first ever job, actually, we had async kind of like everywhere to download, to process these 3D files. I'm also hoping that we can do some audio programming, so being able to run or to load audio files from a disk and then kind of run them, and provide APIs for users to be able to write their own applications with our stuff, right? So provide APIs to create windows, to draw 3D stuff, and very basic like audio programming. That's what we want to do here. Is there a huge difference between C++ headers and C headers? No, they're just, I mean, the idea is the same, right? So it's just that where you define your API so other people can include your functions or include your classes and then use them in your code. So that, it's the same idea. I would recommend Quizlet Code, which, by the way, welcome to the stream. Just read about compilation units. So you want to Google compilation unit and understand how compilers kind of compile object files in C and C++, so you can get a better understanding of what headers are for. Ever used IMGUI? I've used IMGUI before. It's very easy to use, to be honest. And I was thinking about using IMGUI quite a lot, but yeah, I thought since we already have Qt integrated here, let's go with Qt, right? So why not? Anyway, so now we should be able to actually reconfigure this. Now, one of the challenges here. So could not find gtest. Why is it not finding gtest? Did I not do a colon install? I don't think I did I? No, yeah. But one of the challenges here is that my ECS library has been written with C++ 23. And we have, the main ECS library as a C++ module. This project is a C++ 20 project, which doesn't yet support modules, right? So I want to see how difficult it's going to be to actually bring that in here. But yeah, I mean, we'll figure out. It might be the case that I have to actually... Wait, what? So this is still not found. So why is Google Test still not found though? It might be the case that I have to actually change my ECS to just normal header files and C++ files, right? Hello, Slim. Hello, man. How's it going? I'm doing very well, my dude. How about yourself? It's been a while, right? So it's been a while. I was basically watching too much football last week. Then I also went to Alton Towers on the weekend and had a very good time, to be honest. This is something I recommend to you guys. So whenever you're feeling like life is getting a little bit too much, like work is getting a little bit too much and you can't focus, try and do something a little bit different. So in my instance, I went to a theme park, which I hadn't gone for years. And we're talking about like 10 years, 10 plus years, yeah. And it was very fun. It was very different. I spent the entire day doing something that's like not in front of the computer. And it was good to actually just chill out. Good luck in your endeavors. Thank you, Quizzer. And before you leave, dude, if you can like the stream, I appreciate that very much. I went Fort Park. I've heard of Fort Park. Yeah, I guess it's closer to London, isn't it, than Alton Towers? But I've never been there. Not gonna lie, and it sounds like it's. Oh, It sounds like it's kind of better than Alton Towers. It's bigger, but I don't know. It sounds cool, dude. I subscribe. Thank you for your cool content. Thank you, Quizet. I appreciate the love, man. And yeah, have a good evening. Yeah, so no idea why we are kind of still not finding Gtest, because it should be available now on Conan debug, right? So do we have release here? Let's build in release as well, just in case. Please like and sub. Yeah, please like and sub. I wasn't expecting to get a lot of people watching today, just because it's the first stream of the series, and it's usually with these streams we're just talking about ideas and yeah. So I think looking at all of this, I do have a pretty good idea of what I want to do though. So obviously we're going to be using the ECS, right? Oh, let's change this to that. So one of the things I want to definitely do is to have 3D object support, also 3D model support. I want to have like functions that will render 3D object stuff. We want to have audio rendering, like a very basic audio rendering engine as well. So, the users will provide files that they want to load from the disk, and we will kind of load and mix those things as they come, right? And this is going to be, I'm going to try and do it very, very simply, but one of the things with audio programming is that, if you've done it before, you know that it's very, very difficult. It's extremely difficult to do audio programming. Now, luckily for us, we do have projects where we've already integrated some audio engines to C++ before. And, we have things like Boost's single producer, single consumer, like circular buffers, which are like atomic ways of like loading data into a queue and rendering that with like things like port audio or even the Qt audio stuff. But it's still very, very difficult, and it's still going to be like a long time to finish this. So maybe we'll focus on the actual rendering side of things first, right? Now, this is going to be using a library called async, right? So I will have a library called async. You can't spell async without simp. And this is like an open source library that will that allows users to just I think load like over 30 models or something. I'm not entirely sure. Let's see the latest documentation. So it supports quite a few different file types, right? So installation, dependencies, data structures, support and feedback. Nope. I'm trying to find the list of like actual object files that they support. But maybe that information is going to be difficult to get. Maybe it's going to be difficult to get. Oh, there you go. That was right in front of us in the introduction. So these are all the files, all the file types that async supports. So you can load in like Blender files. You can load in 3ds files. I don't know what they are. There are some AutoCAD files as well, like FBXs. It does support that and whatnot. What graphics API do you use for that engine? Welcome to the stream, Mustafa. And we're just starting, dude. But it's gonna be OpenGL, just an OpenGL, very simple OpenGL rendering engine. I was telling Arkonaf just 5 minutes ago is that it's not gonna be like a massive game engine. It's just gonna be, I'm just planning out how I'm gonna provide some APIs for people to just draw 3D meshes. That's all. Anyway, so we're going to be using async for that model rendering engine stuff. As someone just asked, the whole thing is going to be OpenGL. Let's try and put that in here. I think it's 4.2 that we're actually using. This is the whole thing. Now for a superset of that, this is actually being pulled in with Qt, right? That's the window creation. So this is Qt 6. That's what we're using here at the top. What OpenGL version are you using? I hope this just answered your question. It's 4.2. And audio rendering engine. I mean, this is, again, I mean, Qt has some stuff on it, but SBSEQ. So Qt has some audio rendering stuff, but the problem is that I couldn't really get it to work very well. So maybe we'll have to rethink this later on. Now I want to just make it pretty. There you go. So this is what our game engine is going to look like in the end, right? So that's what I'm hoping to kind of get achieved. And these are all the parts of our game rendering engine. So this whole big box is going to be the actual rendering and window creation, right? And this box here is going to be the the 3D rendering APIs. Can I quickly just group all of them? Yeah, I can. And this is the audio rendering engine, right? I guess I'm just going to put this in a box like this. So this is in in simple terms what we're aiming to achieve. Yeah, I mean, right now we have a very basic way of drawing things with OpenGL. If I can get it to compile. I have no idea why it's not finding gtest. Absolutely no idea. So this is actually an error coming from the ECS. Oh yeah, that's something I completely forgot. Alongside this whole thing, we also have the ECS, right? So this is basically just one box here where we have my own ECS, which is called May ECS, Matt's awesome ECS, and that's what's giving you the the ECS stuff. Not much more than that, really. There you go. Are you clearing make cache? I am clearing the cache, yeah. So it's whenever you're working on VS Code and you have CMake integration, you can do delete cache and reconfigure. That clears the cache for it. What I was going to check is that we actually have the gtest config here, hopefully. See, we don't actually have that, which is interesting because my column file should have gtest here. Ah, you see, I don't actually have gtest, so I didn't actually put it in the first place. That is my bad. So we can fix that. We can fix that right now. So let's include gtest in coding. So gtest is going to be here, self-load requires. So we save that, and then we install it. There you go. So now we're actually getting that. So yeah, in theory, you should be able to actually include ECS in here. I have a few different concerns though. So as I said, the ECS has been developed with C++23 in a modular way. So we do use C++20 modules in there. And I don't think that's going to work for us. So we're going to have to like shuffle some of the ECS stuff into just normal C++ headers and C++ files, right? Unfortunately. And I think that's a good choice anyway, because people will definitely not be using the latest and greatest compilers when downloading a project or when using a project like this one. So yeah. So we have that. Now we just need to do the debug as well. The debug build real quick. Okay. Now we can reconfigure, and I think that's all of the dependencies that we needed for the ECS. And for those wondering, I'm bringing the ECS with CMake fetch content here. So this whole thing is bringing my ECS from a different repository. Maybe I should actually put these all together. Okay, so we have build everything, and we can hopefully still build, right? We haven't really changed any code, so I hope that this still builds just fine. And I hope that we can also run the program. Except we do not. So the following thread is treated as an error. What the following is treated as an error. Result of 32-bit shift implicitly converted to 64 bits. Right. Let's try that now. And this is actually a bug in the ECS code, as you can see here. It's part of my ECS code. So are we getting further? We're getting further now. But this is something I need to fix on the other project, right? Now we have 32 different projects. So argument conversion, constituent flow, possible loss of data. Man. Yeah, as I said, this is not going to work. This is just not going to work. Because we don't have modules enabled, right? Could not find module ECS. So just by including the ECS in a project that doesn't have C++ modules enabled, we get all of these errors. So let's see if we can, if they look easy to actually kind of fix, right? Because if not, we can just disable it for now, and I can just do it on the side. So argument conversion from const int to float, possible loss of data. You draw a circle. What is draw a circle? Okay, whatever. So this should be a float, right? So something like that. I do want to know if it compiles if we just like remove these very easy to fix problems on the ECS. And the reason why we're getting all of these errors on the ECS code that we weren't previously getting is, one, we have a different compiler. So we have MSVC now. I'm working from my Windows machine in this project, and the ECS was being worked on Ubuntu with Clang and GCC. And two, I believe we actually have more restricting flags here with this setup. So with this setup, I actually have, let's see what warning flags we've got in a CMake preset for MSVC. So I am using, we can see here what kind of flags we have now. I can't get comfortable on this freaking chair. Unix, there you go. So we have W4, which is the highest level of warnings that you can get. WX, which turns the warnings into errors. So yeah, I mean, it should be fairly compatible with the, W error and W all flags, and W extra, I guess. But we obviously have like differences in warnings between MSVC and GCC, and this is what we're getting. And there's nothing much that we can do. So the following warning is treated as an error. Which one? There's so many of them. I don't know where to start, really. Right. So warning, registry, circle, unrect position, get was declared deprecated. Yeah. So I mean, yeah, this is not something I'm gonna. So I declared it deprecated just because I'm gonna remove the use of this one. Oh. Yeah, I'm very much just like considering just commenting this out for now and fixing this later on, to be honest. As I said, getting the ECS in a format to actually be brought onto this project, which doesn't have modules in it and has more warnings, is going to take a long time. So maybe we're not going to do that in this stream. So point is, I will go to my CMake lists and then just comment these lines for now and put a to do here, right? So the to do is to basically release a stable version of the ECS without all the C++ modules. Yeah. And then once we do that, which will be probably in the next few days or so, we can do this. But now let's build it. Yeah, so it still builds. We haven't actually changed any of the code. And please, there's going to be quite a loud noise if I don't turn my volume down for you guys. And we just have this, right? So we just draw a cube where the vertices are not being properly displayed for some reason. Yeah, which is very interesting. We'll figure that out. Maybe something to do with Z-buffer, or the clipping is not properly working. And let's turn this into an actual thing, right? So let's begin to think about it. So let's just take it back to the plan. Let's see what we can achieve quicker, right? So we do have window creation already. Obviously, we need to make this a little bit nicer to the user, so they're not going to be kind of creating their own version of the triangle window here, which is what we have. So yeah, we can maybe provide this concrete type or this concrete class. Sorry, this final class as part of the API somewhere, right? Yeah, so maybe let me just write something down here. So we probably want to expose the window creation through the API. And we're probably going to have like a pimple sort of thing where the user doesn't actually have to know they're using Qt, but all of our like window classes, window functions will call upon Qt stuff. So cool. And let me see what we have here so far. We already have a GL abstractions class. And I guess this will be more of a Qt abstraction. Yeah, we have GL window here, for example. Yeah, cool. So that is going to be achieved. I mean, the plan for this would be expose window API. We're going to have a few of these, right? So what else do we have here? We somehow have to expose the OpenGL functions as well, because these are all being accessed through Qt's OpenGL classes, right? So yeah, I'm not sure how that's going to work, but we're going to have to figure it out. Okay, I mean, those are the 2 points I can think of for this. Now, on the ECS type, we definitely need to unmodularize the library. We need to get rid of all the current compiler warnings, right? Which are errors, unfortunately. Now, on the audio engine side, I have no idea. I mean, we need to revisit this in the near future, because this is something I've not touched in a while. So if anyone knows about audio programming, please let me know, because you're going to be quite helpful to me. Now, on the actual 3D API, right? So what do we do here? So we want to expose mesh classes, right? So the user will be able to create like mesh objects. We also want to expose like model loading APIs in here somehow. What else do we do? We want to play with async on one of the streams, definitely. Am I spelling async right? Yeah. Can't spell async without as, which is interesting. And yeah, I mean, that's all I can think of now. Now, what is the best place to actually start in this stream? Does anyone have a preference? What do you guys want to work on first? It can't be audio rendering though, because I don't have enough in me right now to actually start working on this. So you can pick on the ECS work, you can pick on the async work, you can pick on the, I guess, window API stuff. I mean, for me, the most interesting one would be trying to expose the mesh classes and stuff, right? So having to take a, taking a look at what we currently have and improving that. Because if I'm not mistaken, we do have a mesh stuff, right? So we do have mesh data somewhere in here, like here. So we have a mesh class, right? And what do we have in there? We have a mesh class, which has some actual vertices data. We have shader program. But where is the color on this? Okay, I think maybe I already know. So this contains all the drawing data laid out as, there you go. So we have X, Y, and Z, which are float numbers between 0 and 1. And then after that, we have RGB data, so the color data, and the UV, right? So ideally, yeah, so our work later on is going to be turning whatever data async returns to us, which will be, I guess, will be like a scene graph. It'll be like a scene graph structure somehow with like materials and whatnot into this data object here, which we can do. And these are the indices we want to draw. Gee, what happens if we just comment some of these out? Is it just going to draw one triangle? If I rebuild this, perhaps I want to fix one of the issues that we have first with rendering, which is some of the faces that have been rendered are not properly being displayed. So this is one of them, right? This is one of the triangles that we're drawing. Now let's see if we can reproduce the error without drawing all of them, right? So for example, we draw phase 6 and phase 1 and see what happens, right? I'm not sure how I did this, but this should, in theory, if I did it properly here, they should, in theory, be like opposite each other. So let's see what we have. Okay, no, that's, oh yeah, that kind of shows that kind of reproduces the error, right? So the first face, whatever that is always being drawn in front of the other one. Now I'm pretty sure this is probably because of Z buffer stuff. Yeah, so def testing, that is something I've not enabled, right? So this is the Z buffer def testing. So let's have a look. Oh, I did enable it. Oh, interesting. Interesting indeed. Apparently I did enable it. So the renderer, which takes in a bunch of world information, width and height, refresh rate, retina scale. We enable def testing with def function is always gel always. Maybe the def function isn't the right one. Oh, that sounds about right, right? Let's take a look at docs.gl and see. What am I looking at? Gel depth function. Let's see what options we have here. So that function specifies the value used for depth buffer comparisons. The function specifies the depth comparison function, never, less, always, equal. Right, so let's see. We're using always, which always passes. Passes if the incoming, so it's one of these. Greater. Okay, I'm not sure which one is. The initial value of function is less. Initial, yeah, so that is probably what we're doing wrong. Hello, SOP. Even if a depth buffer exists and the depth mask is non-zero, the depth buffer is not updated if the depth test is disabled. In order to unconditionally write to the depth buffer, the depth should be enabled and set to GL always. What if we use less though? Yeah, so we basically what we do here, we take all the meshes, the rendered meshes, and render them. Right, so rendered meshes is another thing. Ooh, okay. What does that do? Okay, I see. So rendered meshes is actually the OpenGL abstraction that I've written for drawing some blob of data, right? Some vertices. So we have the buffer ID, we have the vertex array, and the element buffers here. You should maybe use GF, yeah, so GLS. We'll try that now and see. So I've got GLS. Test each one by one. Yeah, good. That's a good advice. When you don't know what it does, test one by one. Now less just never does it. So we got a black screen with less, which is interesting. That's really weird. Now let's look at more, right? So let's see if more will write to it. So the opposite of less is greater. Let's go for greater. Now let's go back to whatever we were. So 1.3 GL greater. And build that guy. Also, because we don't really care about the we don't care about the audio stuff, right? So we can just remove all the audio stuff here. I don't really care about any of this, to be honest, so let's remove it. And is it still going to compile? Just so we can get into the application straight away. Okay, now that's weird. What? I can't really... I know these functions are supposed to... Sorry, these values are supposed to kind of dictate how the Z buffer is being written to. But I have no visual... Yeah, I have no visual, like, idea of what this is actually doing, which is interesting. So greater doesn't work either. Right? Let's try a different one. Equal, less than equal. Yeah, so always seem to always show them. Never passes. And we run def testing, right? So just... But are you clearing the color and def buffer bit before each frame? That is a good question. That's a good question, indeed. So I have the window here, which renders. Ah, that's perhaps what I'm not doing, because this OpenGL window function is indeed, being called here, but I am not actually calling them in my overridden function here. So the viewport, so clear. That's what I should be doing. You see, I was only clearing the buffer bit. Do you know the number 1 C++ programming rule? No, I don't, Sopu. Let me know. What is the number 1 C++ programming rule? Okay. Let's try less again, which is the it looks safe, then it is. It's definitely not that, I'll tell you that, dude. It looks safe. It has 10 different... There you go. Yay. So we solved that issue. So now, def testing is working fine. And for those who don't know, what just happened here is that we had a problem where one of the viewers rightly pointed out, Burfu, welcome to the stream, by the way, man. It's nice to have you here. He pointed out that we're not really doing def testing. And in OpenGL, there is this idea called def testing, which essentially tests how far from like the view a particular vertex is, or a fragment is. So it doesn't actually draw things that are behind a particular face if it's occluded, right? And the whole thing works with this algorithm called Z buffering, I think it is. So if you are interested in that, take a look at Z buffering. It's not that complicated, but it does take some time to understand it. But the main point is we should now be able to go into our main application and comment out all of the faces, right, in here. So game engine without triangles, I mean, the triangle. You want the triangle. I can, I'll give you the triangle, which is this one here. I guess that's what you mean, right? But it will rotate. It's like a step above the triangle. My triangle actually rotates. So anyway, this is the hello world in OpenGL programming, I guess, right? There you go. Now, if you're happy with that, you'll be even happier with this, which does a whole cube. And this is really interesting stuff, by the way. I haven't really mentioned this, but what we did here is like we have a contiguous array with all the vertex, color, and UV data that's not really being used at the moment because we don't have textures. But we do what's called index drawing. So instead of like repeating this data over and over again, OpenGL has a mode where you can draw a particular triangle based on the index of the data, of what the data is. And that's what we're doing here. Now, a step above this would be something like instance drawing. So instance drawing in OpenGL is where you draw like the same mesh multiple times, and perhaps one or two parameters change. But it's you know, just things that you can do to make your program a little bit more efficient. So instead of having to like duplicate most of this data over and over again, I define each like vertex once and I just refer to it in here, right? So this is crucial. This is very crucial in how object models work, 3D models work, because you know, you'll see once we get to that, once we have async coming in here and we're loading something like an object model, that object model is going to be probably stored in mesh objects in scene trees, where each mesh will kind of have like the raw data and then indices kind of referring to that data, right? So each triangle should be pi over 3 radians, the classic triangle. Yeah, so you're talking about the equilateral triangle, is that what it's called? This is not what we have, dude. This is something else. But, you know, things are looking good, right? So we have a cube that works now, right? So where can we take it from here? I kind of want to revisit all of the APIs that we have and make sure that they are usable. You see, I've got like a mesh object here, but I also have a rendered mesh somewhere, which I don't really know what it's for, to be honest. Let me just close everything because this is getting too much for me. Game engine, okay, so classic. I don't know. In Poland, we call it, fuck me. I'm not even going to try and pronounce that. No, fuck it, I'm going to try and pronounce it. Rolnobokni. Is that right? Did I pronounce it correctly? Let me know. Rovno. Is it Rovno Bochni? I'm gonna say that's how I would pronounce that, but it's probably not right at all. Yeah, I'm pretty sure it's an equilateral triangle, right? So equilateral triangle. This is, you know, the 60-60-60 there that you mentioned. Equilateral, all the sizes have the same length. All the sizes are the same, right? That's what it means basically. But yeah. Rolnobochni. Alright, I see. Now it is time to create a Minecraft clone. Yeah, now it's time. You know, step number 2, just create some voxels, right? That's what we do. Jesus. Right. So yeah, I just wanted to take a look at this mesh thing. So this is just the basic struct with a vector of floats for the data and the indices, which are unsigned integers. Ah, okay. So we also store the ID for the shader program that is running this, right? So I guess when we use that rendered, yeah, so we have this rendered mesh, which is yet another structure. Ah, okay, so rendered mesh contains a mesh object, which has all the data in here, I guess, and also the OpenGL specific data. Now, one of the things I would argue is I think the shader program should really be on the rendered mesh, right? So yeah, this is all that we should do. So let's put that in here. Let's make the API a little bit better. So pi over 3 degrees are for kids. Yeah. Since I learned radians, I am not using degrees anymore. Yeah, I mean, degrees are superior. Everyone knows that. Okay, yeah, we moved the shader program ID into rendered mesh because this is the actual thing that seems to be holding the mesh data and also the OpenGL specific data, right? And this is in my GL abstractions, which is okay. I mean, where is my mesh object? This is also in GL abstractions, okay. But I would argue that this is not really a GL abstraction, though. This is just an abstraction of a 3D object. That's fine. Anyway, so let's build this, get some errors, and then fix them. That's what we're going to do now. Right? This is what's going to happen. We're going to get some errors. Right? Good. Good, we did. Yeah. So shader program doesn't have a designator there. I know you guys can probably see what the next step is. I'm not sure if we're going to be able to do it in this stream because quite honestly, I'm going to call it off in 20 minutes. But the idea is to get async to load object file, and then we turn it into a mesh. That's what we're going to do here, right? But in the meantime, we also want to make sure that these APIs are kind of easy to use because at the moment, they are definitely not. I'll tell you that. Now, we did compile, which is not ideal because rendered mesh should really have should really have something here. So mesh is going to be that, and then we have the buffer is equals buffer ID. Vertex array object. So this is vertex array, which keeps track of all my kind of state. I'm not sure if you guys like agree with this. I know there's some people who have done OpenGL in the past year. I'm looking at Berfu probably. OpenGL becomes a lot easier when you start thinking of it as a like client server thing, right? So essentially, the GPU is your server, and you're setting like the context. Let's say like when you draw something, you're saying, okay, point to this vertex array object, point to this, set all of these uniforms, blah, 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 and then render. So you are setting the context, sending it to the server to render, and then you're doing it all the same. Like you're basically just making like client server calls. Subscribe and like. Till next time. Thank you, Berfu, and yeah, enjoy your night, dude. So this is the element buffer. Shader program. Oh gosh, what is this? I have so many windows open. I keep forgetting that whenever you debug something with VS Code in Windows, it doesn't really close the goddamn console, and it's really annoying. Really, really annoying. What the hell? Right. Now, I kind of mistakenly removed a line of a file. I think it was in my main here. But really, I want to know where I knew about my shader program, basically. So shader program is equals to 0. I see. So in here, I didn't actually know the shader program. I just assumed that it was going to be 0. I may have already mentioned this once, but there's something called Intermediate Graphics Library, IGL, on GitHub. I've not looked at that, no. So how does that differ? Well, that's a Facebook project. It's a media graphics library. Is it like an easier to use OpenGL? Intermediate graphics library is a cross-platform library that commands the GPU. It provides a single, low-level, cross-platform interface on top of various graphics API. Ah, okay, so this is a level above OpenGL. It wraps around it. So it supports Vulkan, it supports Metal on Mac OS and iOS. That's really neat. That's really cool. It also supports OpenWebGL. There are examples in the repo. That is amazing, dude. That's really, really good. I like it. So what, is Facebook just building this? I love the commit messages, by the way. Is Facebook just building this like superset of not really a superset because it's a wrap around all these like OpenGL, Metal, and Vulkan libraries. But are they just building this so they can use it on their VR stuff? Is that what they're doing? That sounds interesting, though. That sounds very interesting indeed. Yeah, no, that's cool. That's definitely cool. Degrees are superior because there are more of them. Degrees are superior. Todd Wasson. I have no idea what you're talking about, dude. You might welcome to the stream, but you're gonna have to explain that one. Is there like an example I can see, like of this rendering on the web? There should be, right? So, Facebook. Oh right, you're talking about actual degrees. Yeah, never mind. I thought you were talking about college degrees for a second, and I was like, what does it mean? Degrees are superior because there are more of them. Yeah, that's the thing. There's an infinitely many number of degrees, right, depending on the resolution, and also there's an infinitely many of radians. So which infinity is bigger? That's a question that you may answer if you've been to a maths lecture at university. Which infinity is bigger? There are like, that's, you know, some, if you guys are interested in maths, there is this idea of infinity sizes. So for example, you may know that the natural numbers are like 0, 1, 2, all the whole numbers that are positive, for example, the natural numbers, it's an infinity, right? There's an infinite number of natural numbers. But if you take in, for example, the rational numbers, right? So the 0.0001 pi square root of 2, infinity there, there's an infinite number of them, but that infinity is much, much larger than the infinity of the size of natural numbers, because you can't enumerate them. So infinity isn't actually a number. No, infinity is not a number. It's a concept which has a weight to it. You should do maths at university, SOP. Infinity IGL. So Facebook IGL, WebGL example. I just want to see this thing running on the web, to be honest. Online example. So has no one done an application that actually runs on the web? Because they seem to, IGL seem to compile with mscripting. So it's interesting that they haven't done it. But yeah, we're not going to find it today. Web developer would say infinity is none. It's not a number. Yeah, that's true. That's a good little joke. Anyway, so we were on this, right? And the point where we actually have a rendered mesh, which is inside add mesh, render.add mesh. Ooh. Where is render.add mesh? There you go. So this is where we do 0 here, right? Triangle mesh, and then we also have in here caps lock was on. We also have an unsigned int. Then we have the shader program. And down we're asserting a bunch of things here, aren't we? We are asserting a bunch of things in here. Do I even need that? No, I don't need that. Because I already have a shader here. Shader.getID, that's the one I need, right? So yeah, assigned integer. Okay, yeah. Shader ID. I'm just gonna say that exists, right? Because in here we can do shader ID and just dereference it. That is it. Right, so now we have a way to get the shader ID, the proper shader ID. Right, so that's what we're gonna do. I currently learn physics from all high school classes to make my teacher cry. Nice. He would think I'm just another stupid student. I currently learn physics from all high school classes to make my teacher cry. I mean, it seems like you're doing more than the other stupid students, right? So you sound like a smart guy, my dude. Keep going, and you get very good at it. All right, so that still works. We haven't broken anything. So what we did now is we actually use the proper shader for a renderer. I think the idea is that every renderer has a shader associated to it. Let me just see that, because I'm not entirely sure. So we have a renderer here, and we have the shader program, which is a map of unsigned int to shaders. Ah, okay, so maybe, yeah, this actually has many shaders. So how does this actually work? Like, how do I get which meshes are for which shaders? So for each mesh, I have to enable a shader, right? Shader unused. There you go. Shader use. Ah, okay, yeah. So there's another improvement that we can make here. So although it seems like our renderer supports many shaders, we are hard coding the first one, always. So yeah, we always use that one, because ideally, right, the kind of pseudocode that we would have here is like for each shader that we have, we are going to get all meshes for that shader associated with that shader, and then we render them, and then we unuse shader, which is not quite what we have here. So in here we see that we always have shader 1 active, so whatever shader gets returned to me is going to be active here, right? Which is fine. That's another little improvement that we can do. But yeah. Yeah, and then in the end of this whole thing, what we want to do is, like, instead of having the render kind of contain or own its own meshes, because we have here a renderer that has you can see a vector of rendered meshes here, right? So instead of having that, the idea here is to have to remove this and use the systems and turn this into a render system for entities that have rendered mesh components, right? That is the idea here. That's where the ECS is going to come in. So we're just slowly going through the code and slowly figuring out what I did quite literally nearly a year ago, because the last time I did this entire code was October last year. But yeah, we're trying to create a plan for ourselves here. Oh, not classes, I mean grades, English is, oh, no worries. I will have already knowledge from all grades since the beginning of first grade of high school. You won't expect that. That's gonna help you out, man. That's gonna help you out quite a lot. You better get all A stars. Get 10 out of 10 in all your tests. So yeah. Now before we actually call off the stream, what can I do here? So for the next stream, right? So the plan for the next stream is, let's move back to XCalidraw here. I think we're actually going to have to work on this first, just because this part will require the ECS to be done, right? So this part of the project, where we actually provide APIs that the user can render model files, will require the ECS to be running, so we can properly use the mesh components, right? Like they're supposed to be called. By the way, why don't you use fixed size integer types? Fixed size integer types, what do you mean by that? So do you mean like we have fixed size integers already? So in int32, for example, integer is just a fixed size integer. There are fixed size floating points. I'm not sure if that's what you meant. int32. Yeah, I mean, to be honest, in this case, it doesn't really matter too well, because if you look at some of the documentation for, if you do GL create program or create shader, right? That's a good example here where it returns some integer. The actual definition of GL uint is just a unsigned integer, so we got to make sure that all the types that we have internally in the program have to match whatever we are getting from the framework. And yeah, that's mostly the reason why I'm using this type. So for example, width and height here is just because I'm sure that in render somewhere, wherever I'm using this, they have to be ints, right? So they have to be integers here. Or actually, they have to be doubles, but you get the gist, right? So it doesn't really matter in this case at all. Integer in C++, most of the platforms, unless you're using like some weird platform, it's going to be 32-bit integers anyway. And if you're representing width and height, you're not talking about going above like 4 billion anyway. So it doesn't matter. that's the point here. Now, if you're working with network stuff, so we're sending like packages across the wire, and you're serializing and deserializing data, then you have to be sure that you have, what size of types you're sending across, which means you should probably use fixed width integers to represent like values and stuff. But in this case, it doesn't matter. That's the reason. But anyway, so let's do that. For the next stream, I will definitely work on this. So we're going to be unmodularizing the ECS library. We're going to be basically let's spend like 2 hours on just making sure that the library is ready to be released. So by that, I mean, we will remove all the C++ modules because, I don't really see any advantage of using them for now, to be honest. It only seems to increase compile time and difficulty in integrating libraries with modules in C++. IntelliSense and VS Code is another thing. It still doesn't work after like 4 years, but it is what it is. So we're going to modularize that, turn things into a combination of header and C++ libraries. We're going to be putting some export headers through CMake, and we're going to be installing things through CMake. only so we can include this whole thing into our project, right? That's what we're going to do. So that will be the next stream. And the reason why I'm going to do that is so we can then move on to playing with async. So async is probably going to be 2 or 3 streams away. But this is where it's actually going to get interesting, because we're going to provide some APIs to load 3D models. So yeah, if you don't have an idea to stream in the future, you may try Elixir. So Elixir, yeah, I've never actually tried that language, but yeah, it's a good idea. Thank you. I may try that in the future. There is a backlog. That's the thing. So there's a backlog of streams that I already need to do. So some people already proposed some projects for me to review, and I just haven't done the streams because I haven't had time. But this has been in the backlog for a while as well. So start creating a game engine, just because I want to learn more about how game engines work, and this is a good way to do this. But yeah, this is going to be more of like a long short stream. So we're going to be doing this for like maybe I'm going to say half a year, because that's usually how long these projects go for. But anyway, thank you all very much for joining the stream today. I'm actually going to call it a day here because I'm very tired and I need to get some rest. I've been on the computer most of the day. But I do apologize for not being very active. I will start being more active. I will try and do another stream on the weekend, maybe Saturday or Sunday. So stay tuned for that. And I will also start working on more videos. I haven't really done any proper videos on YouTube, like tutorial videos that I used to do, which is basically the bread and butter of the channel. So I need to start doing those again, guys. Muslai, yo, hello Muslai. I mean, it's nice to see you here, dude, but I'm calling you a night soon. But anyway, thank you all very much, guys, and stay tuned for the new videos. It does help me out quite a lot if you just like the videos and comment on stuff. You know, getting engagement is good as well. But, you know, have a good night to you all, even for the people who just joined, and I'll see you next time. Bye-bye.